The Oklahoma City division of Supersport Inc. produces footballs and basketballs. It takes 4 hours on machine A and 2 hours on machine B to make one of their footballs. To make a basketball, it takes 6 hours on machine A, 6 hours on machine B, and 1 hour on machine C. Machine A is available for 120 hours per week, B for 72 hours per week, and C for 10 hours per week. If the company makes $3 of profit per football and $2 of profit per basketball, determine how many of each ball they should make in order to maximize their profit.
Now let's solve the problem. First, we have to clearly define our variables. Let's have x be the number of footballs and y be the number of basketballs. Now we have to consider our constraints. You can't have negative amount of footballs or basketballs, so x and y both have to be greater than or equal to 0. Then you have to consider how long each ball can spend in each machine. So we're going to have 4 hours for each football in machine A and 6 hours for each basketball in machine A. And machine A is only open for 120 hours per week, so the amount of time spent in the machine has to be less than or equal to 120 hours. It's the same for machine B, except machine B is only open for 72 hours per week, and each football spends 2 hours in machine B, and each basketball spends 6 hours in machine B. Machine C is special because only basketballs spend 1 hour in machine C, and machine C is only open for 10 hours per week, so the amount of time spent in machine C has to be less than or equal to 10 hours.
Now we create a function that shows the cost of each football and each basketball, making the maximum profit possible.
Each line in this graph shows a constraint made in the previous section. The shaded area shows any possible answer to the question. But we're trying to find out the combination of footballs and basketballs that will result in the greatest profit. The corner points of the shaded section show any solution that could be most optimal in this situation.
These are the corner points in this situation that could potentially maximize the profit. So now we must plug in the corner points into the objective function to find the optimal solution. In this, we are going to use the corner point 30, 0, in which 30 is the number of footballs and 0 is the number of basketballs. Each football costs $3, so we multiply 30 by 3, and then each basketball costs $2, but since there are none, we multiply it by 0. This brings us to our next step, where we find out that the profit of 30, 0 would be equal to $90 plus $0, which is $90. We would do this for every corner point, and we've written them below, that the profit of 0, 10 is $10, the profit of 6, 10 is $38, the profit of 24, 4 is $80, and the profit of 30, 0 is $90, and the profit of 0, 0 is $0.
So now that we've done all the hard work, now we have to state our answer in the context of the question. So, if Supersport Incorporated made 30 footballs and 0 basketballs, they would have a maximum profit of $90.
That's all well and good, but what if we could change our maximum profit by changing the cost of each football and each basketball?
In this case, we've changed the cost of a football to $5 and the cost of a basketball to $8. This changes our objective function to profit xy equals 5x plus 8y. This optimizes the separate corner point 24, 4 with a maximum profit of $152. The other corner points are as follows: 0, 10 equals $80, 6, 10 equals $110, 30, 0 equals $150, and 0, 0 is still equal to $0.
Hooray! Thanks for solving our profit problem. I hope you have a great day. Thanks for watching.